epicenter is based on knowing that P waves and S waves travel at different speeds, but they travel at constant speeds. So let's do a quick review of this. Then I'll work you through the first part of the activity. Yes. Okay, good. Well, let's back up just a second. So who can tell me about P waves? P waves, yes. Okay, so they're the first to arrive at someplace distant from the earthquake. First arrival, primary waves, and they're compression waves that kind of stretch out like this. You all made them with your slinkies yesterday, right? Yes. What's that? Yeah, they're the least destructive, which ends up being really important because if we, as I mentioned yesterday, um, if you can warn people when the P waves come and then they can get to safety or whatever before the more damaging ones come. Yes. Yes, do S waves. And what does their movement look like? What does their movement look like? Good. So side to side, secondary waves, second to arrive. So then the distance between the arrival times, we did the example of two people running a race, or also came up with the excellent example of thunder and lightning. If you know the distance between the two, the distance between I see the lightning, how long till the thunder, that can tell you how far away the storm is. If you have the P wave and know how long until the S wave comes, then you can tell how far away the earthquake is. So this is just, here, this is a little messy. Let's clean this up here. So for example, we could take this example and say an earthquake occurred in California. In San Francisco, the P wave arrived at 8:15, the S wave at 8:20. In Los Angeles, the P wave at 8:17 and the S wave at 8:27. Which city is closer to the epicenter? So take a quick look at that data, and as a table group, maybe you could tell me which city is closer to the epicenter. Okay, so San Francisco is closer to the epicenter, and how did you figure that out? Okay. Okay, so in San Francisco, from 8:15 was the P wave, 8:20 was the S wave. That's 5 minutes. See, easy math. And in Los Angeles, 8:17 and 8:27, 10 minutes. So obviously, um, the LA is farther away. There's probably one other way you could tell that San Francisco is closer. Yeah, that's true. That's true. So you know that if the P waves hit San Francisco at 8:15 and not till 8:17. But with this added information, you can actually also figure out how far away it is. Now there's one more piece of information we need, which is how do you know how fast they travel? So check this out. This is one of those nice times in science that what you do is you actually just look it up on a graph. And this is the P wave and S wave data. We actually have an even simpler graph that we can use. But so the arrival time in minutes, P wave, S wave. And so with this, and this is obviously straight out of the textbook, but this shows you how fast each one of these waves travels. So distance from the epicenter, S waves, P waves. So you know if the S wave took 4 minutes to get there, then you can see that it was 1,000 kilometers from the epicenter. So let's do this first activity together. start it together, it's going to look like this. And we are going to determine P wave and S wave. Basically, what's going to happen is if you know that the epicenter, if you read off the graph and find out that the epicenter was 1,000 kilometers away from, I don't know, Denver, then you know that it could have been, the earthquake could have been anywhere in a circle 1,000 kilometers away. Does that make sense? Let's do this example. Let me pass this out for you, and we'll get started. Now, you should have been able to, using the data you filled in, which should look like this for the P wave and S wave times. The distance here is 5 minutes. And these numbers here, you get from reading off of the graph. The graph is in the textbook. The graph is also on the back side of the handout. So reading from the graph for 5 minutes between the two, it's about 3,200 kilometers. For 6 minutes, about 4,200 kilometers. It's okay if you don't have these exact numbers. That's just one of the errors that's kind of there. And then you use your compass, and using the scale on the bottom of the map, you can see how big the epicenter area should be. So if you see here, you make yourself a line for that distance. This line here is about 2,500 kilometers. 2,500 kilometers was the distance for Sitka, Alaska. So you put your compass here and swing a circular arc, and this is the circle it makes. The earthquake has to be somewhere along this line of 2,500 kilometers from Sitka, Alaska. You do the same thing for the line from Honolulu and also the line from Charlotte, North Carolina. And as you do this, you make the circle, and the circles should come together. In reality, depending on your measurements, they may not come exactly together as you're seeing here. But here, if we switch this back over here, you're going to get this arc that's going right through here. All right, my pen's not working. That's okay. And that makes the epicenter come here fairly close to Southern California, which makes perfect sense. So then after you finish this one that we've done together, on the back side of this sheet is another map, another set of data, and you need to find the earthquake based on that data. And then there's a set of questions asking you about where were the earth epicenters, what cities are closest to them, how far in kilometers. So do those for earthquake 1 and earthquake 2. That's EQ1, EQ2. You will do this. You will turn in this with your lab on either Friday or Monday. So yes, if you didn't finish it, it's homework, but you do not have to do it tonight. This flipped lesson should help you if you didn't fully understand how to do it. Hopefully this can help you work through it. And finally, if you go back, if you are still a bit confused, this is from the textbook. The textbook information, oops, let me get it on the other page here. Page 176 in the textbook is the activity. It's very similar to what I copied on the back for you. Page 176 in the textbook, and that can help you as well.